Okay. Good day everyone. This is Engineer Armando Omanito and our topic for today is somewhat a combination of physics and analytic geometry. So let's have this problem. The path of a fast moving particle traces a circle with equation quantity x minus 3 quantity squared plus quantity y minus 4 quantity squared is equal to 25. It starts at point 3 negative 1, moves counterclockwise, and passes the point 8 for the first time after traveling 7 microseconds. Where is the particle after traveling for 20 microseconds? Okay, so let's have the solution. So we have to illustrate all the given data. So there is a fast-moving particle that starts at point 3 negative 1 here. Okay. So, uh, if we will plot this in our Cartesian plane, so this will be our point of origin, 0, 0. And this is our x-axis, and this is our y-axis. So, x-axis and y-axis. So, we have here point 3 negative 1. So, it's the fast moving particle travels 7 microseconds and then passes at 0.84. Okay. So, uh, if you will notice, uh, this the center the center of the circle of course is at okay 3 negative 4 from the equation. Okay, and the radius, so this is the radius is squared 25, so the radius will be equal to 5. Okay, so so if you will notice, this is a vertical line because they both have uh, a, a similar x coordinate. So both have 3 as their x coordinate. And here is this is also a horizontal line because they both have a similar or the same y coordinate which is 4. Okay. So therefore this is a quarter circle and it consume a total time traveling 7 microseconds. Okay. So, if you will travel another 7 microseconds, so you will complete a semicircle because this is another quarter circle. And then, so it should travel for 20 microseconds. So, we have already consumed 7 microseconds here plus another 7. So, you need to travel 6 microseconds only to complete the 20 microseconds travel from here, from this point. Okay? So this is 20 microseconds. So from here up to this point is 6 microseconds. So if you will travel another 1 microseconds, you will complete a another quarter circle. So therefore, from this point up to this point is 1 microseconds. And this 1 microseconds corresponds to an angle here. Okay, so uh, we separate this figure here, this right triangle formed here. Okay, so this angle here corresponds to 1 microseconds here. So therefore, we can form a right triangle. And therefore, we will use the we will use the radius 5 and then this angle which we will compute. So to compute for this angle, of course this is 90 degrees. Okay, so divided by 7 microseconds for a quarter circle will give us 12.85714 degrees. Okay, so we know now the angle and the radius, so we can get the x and y component of this right triangle by using this formula rec r theta. Okay. Okay, let's continue. So let us first compute the angle theta. So let us turn on our calculator and let us press 90 degrees. So this fractional button here. Okay. Wait. So let us press mode 1 first. Okay. And then, so let us press 90 degrees or 90, simply 90. And then this fractional button here. And then press 7 and press the equal sign. And we will get, and press this SD button here. And we will get 12 point something degrees or 12.85714 degrees. So, okay. So, to compute for the x distance and y distance here, so let us clear our calculator and let us press shift and then this uh, rec button here and then so our R should be replaced by the radius which is 5. Okay, so let us press 5 and then let us press shift and then this comma here and then the corresponding angle here which is 12.85714. So let us press 12.85714 degrees or simply that number. So, and then let us press close parenthesis here. And then, press the equal sign. Okay? And we will get the, uh, the value of x, or the x distance here, which is 4.87464, and the distance y, which is equal to 1.1126. Okay? So, to get for the coordinate of point P, so we have here the coordinate here or the x coordinate here is 3. Okay. So we should subtract the distance x from 3. Okay. So we have here 3 minus the x coordinate the x component or the x distance. So 3 minus 4.87464 is equal to negative 1.87464, which will be the x coordinate of P. And then for the y coordinate of P, okay, so we have here 4, okay, and then so here we should add the value of y or the distance y. So 4 plus this distance, okay, 4 plus 1.1126 is equal to 5.1126. So that is the y coordinate of P. So therefore, the coordinate of P is negative 1.87 and 5.11. Okay. So, to be sure that our answer is correct, let's do the checking. So, we have here the equation of the line, x, quantity x minus, equation of the circle, sorry. We have here the equation of the circle, quantity x minus 3, quantity squared, plus quantity y minus 4, quantity squared is equal to 25. So, replace the value of x or the coordinate here, negative 1.8 something. So, we will substitute the original value for a more accurate answer. And then, we will replace y here by 5.11, okay, quantity squared. And then, so let us compute here let's turn on our calculator and then let us press open parenthesis. So let us press negative 1.87464, okay, and then minus 3 close parenthesis and then squared button and then plus open parenthesis, okay. So the y coordinate is 5.11. So let us use the original value to be 1126. Okay. Minus 4. Okay. And then close parenthesis and then squared button and then press the equal sign and we will get 24.99999 or very much nearer to 25. So this means that our answer is correct. So that's all for today, and I hope that you learned something in our lesson. This is Engineer Armando Omanito. Until next time, and may God bless us all.